Okay, kiddos, so this is going to be our day 7, unit 1 lesson video. So in it, we're talking about the Pythagorean Theorem, 2D distance, and midpoint. So we're starting to get two-dimensional now. Okay, so here's our EQ. So what is a Pythagorean Theorem, and how do we use it? What's our two-dimensional distance formula, and how do we use that? And what is our 2D midpoint formula, and how we use it? Okay, so to get started, let's start with EQ1. So what is the Pythagorean Theorem? So in our do now, we had a picture that looked like this, okay? And I'm using more convincing color. I was asking you guys to find this, and I gave you a hint, right? And the answer to find it was really simple. Okay, so you would just use the distance between A and this point here, or the length of this line, right? Obviously, that is 4. Okay, and then you would use the length of vertex C to B, right? So this dx right here, this distance, is obviously 3. And if you do the math, okay, so namely, if we call this A, oops, should probably change colors. If we call this A, and I'll just keep using black, B and C, we know A squared plus B squared will be equal to our unknown C squared, or for us, the distance here between points A and B. So 4 squared is 16, 9 squared is, or 3 squared is 9. That's equal to C squared. We need to get C by itself and get rid of this exponent. The inverse of a square is a square root. And what I do to one side of an equation, I must do to the other. So I end up with the square root of 25 equals C. And of course, our answer is 5. So our distance from point A to point B here is simply, 5. It would be 5 units, right? So that brings us to the Pythagorean Theorem. Here's a basic picture of what it looks like, and basically the proof of it, right? So this is a geometric proof, and if you want extra credit, make one of these yourself. Okay, so here we're just going to practice using the Pythagorean Theorem, right? And we're going to see in a second it's going to apply to two-dimensional distance, but we'll get there. So if I want to know my two-dimensional distance between these 2 points, A and B, well, I can treat this as, well, this is B, A, and this guy is C. So A squared plus B squared equals unknown C squared, or our two-dimensional distance from A to B. Okay? So, and, well, let me back up. So the Pythagorean Theorem basically tells us that if you take one leg, square it, add it to the other leg, and square it, it will be equal to the hypotenuse. Okay? So right triangles, this only applies to right triangles. Right triangles have one leg here that we usually refer to as A, and another leg here, B, that we usually refer to as B. Okay? Legs A and B, we call them legs, or we know that they're legs, because they are the two sides on the right triangle that form the 90-degree angle. Okay? This side that we refer to as C, right? We call it C. It is the hypotenuse. Okay, so legs A and B, hypotenuse C. Okay, so back to my problem over here. So one leg squared plus the other leg squared equals my hypotenuse squared. So that would be 81 plus 144 is equal to our unknown C squared. Okay, so this would give me 225. Take the square root of both sides, and we get our hypotenuse is equal to 15. Okay, so my answer here, my distance here in 2 dimensions, is actually 36 units. Why did I write 36? I had it circled here. I was looking at this 36 because I'm weird. Yeah, that's not what it is. Our answer is 15. Okay, so let's do another example. Let me give myself some room. So, a squared plus b squared equals c squared. Okay, and I'm going to quit calling it c. I'm going to call it what it's labeled here in the actual picture. So, our d2 squared. Okay, so c squared, 25, plus 12 squared, 144, equals our 2d distance squared. Take the square root of both sides. Okay, so 25 plus 144. So I have the square root of 169. Well, that's equal to 13. And that is going to be my two-dimensional distance here. So this guy is equal to 13. One more example. Make sure we've got it. Okay, so this looks a little weird, but again, you can always tell your hypotenuse is opposite of the 90. That's how you know it's the hypotenuse. Anyway, leg squared, it doesn't matter what order you do it in, plus other leg squared is equal to our two-dimensional distance squared. Okay, so 36 squared is going to give me a huge number, 1296, plus 15 squared, which is 225. And that's equal to our two-dimensional distance squared. Okay, so add these two together, we get 1,521 equals our distance squared. But we don't want it squared, we want to just know what it is. So we take the square root, and that is equal to 39. So this distance here, the length of our hypotenuse, or the distance from A to B, right? These two vertices, the distance between them, must be 39. Okay, so Pythagorean theorem's not really anything too difficult to use. Okay, we can also use the Pythagorean theorem to find missing legs. So right here, I clearly see, I know what the hypotenuse is, I know what this leg is, but this guy, I don't, right? So we're going to plug in the numbers where they go. So leg squared plus other leg squared, we don't know what b is, equals hypotenuse squared. 5 squared is 25, plus b squared that we don't know is equal to 13 squared is 169. Then we're just going to subtract. B squared equals 144. And let me go ahead and write that out so I don't confuse you. So I subtracted 25 from both sides. Okay, so 169 minus 25 is 144. Square root of both sides. B is therefore equal to 12. So this missing side right here, B, equals 12 units. Pretty straightforward. Same idea. All we're doing is doing a little bit of algebra. Okay, another example. So again, I have a missing leg instead, right? So leg squared plus leg squared equals hypotenuse squared. So I have 100 plus unknown d squared equals 400. Okay? D squared will be equal to 400 minus 100, so that'd be 300. Square root of both sides, d is equal to the square root of 300. And so right here, what we'll go ahead and do is take decimal estimates. I think. I don't know. Let me think about that for a second. If I want us using decimal estimates just yet. Yeah, we'll go ahead and use decimal estimates for now. So square root of 300. Eventually, we'll learn how to what do you call it? Express these without decimals, but I don't think we're ready for that yet. Okay, so my missing side D is about 17.32 when you throw that in the calculator. Okay, running out of colors here. So leg squared plus leg squared, x squared plus 15 squared equals hypotenuse squared. Okay, so 15 squared, that's 225, x squared, unknown, is equal to 400. 400 minus 225, that's going to be 175. So x squared equals 175, square root of both sides. And we're left with x is approximately 13.23. And just for future reference, in this class, we'll always round to the nearest hundredth with decimals. Okay, so that's how we would use it to find missing legs. So now, let's look at the whole point of this video. How can we use it for two-dimensional distance? Well, you've already gotten an idea, right? So the idea that we've gotten is that basically in 2 dimensions, we can use a Pythagorean theorem to calculate distance in 2D because we just treat that distance like a hypotenuse, right? So right here, at this point, this should be equal to y1. This right here, so if I label x1, y1, like I've got it, this point right here would be equal to y2. Okay, over here, I've got x1 over here. So if I'm looking at it this way, right, I've got x1 and x2. Okay, and we see that we've got a right triangle form. Obviously, these are legs, they're perpendicular. Okay, so what can we do here? Well, this distance right here is one of my legs, and so is this distance. Okay, so if I'm going to call them something, right, I can say, you know, the blue is a squared, the red is b squared, and then the distance from a to b, which I'll do in purple, the distance from a to b, or our hypotenuse, is our hypotenuse c. And that's exactly how I'm going to treat it. Okay, so what is this distance equal to? Well, this distance is equal to the absolute value of y1 minus y2. That's just one-dimensional distance. What is this distance equal to? The absolute value of x1 minus x2. Okay, so if we go back to treating it just like the Pythagorean theorem, right, I can say that this is b squared, like I said, and I can say that this is a, and I shouldn't say squared, just b. Okay, so my Pythagorean theorem basically says this: leg squared plus leg squared equals hypotenuse squared. If I take the square root of both sides, we simply get our distance, or our hypotenuse, is equal to the square root of a squared plus b squared. Okay, or, let me change this. This is driving me crazy. It's writing really skinny. Or, I can say the square root of, I can start substituting a squared, so x1 minus x2, its absolute value, all squared. That's what a would be, right? Plus b squared. Absolute value of y1 minus y2, the distance there. Okay, so let's look at some actual examples, right? So I'm trying to find the distance from A to B here. Well, I need to know my points. So A is -3 by +4. B exists at, what do we got? +3 by -4. Okay, hopefully you can see that. It's kind of hard. Anyway, so let's relate back to what we were talking about. There's one-dimensional distances, right? So if I label stuff, this is x1, y1. This is x2, y2. Okay, and to calculate my distance, right, this guy, my d2, well, that's just my hypotenuse to my right triangle. Or I can just use the formula that I came up with a second ago. This right here. Okay, and that's exactly what I'm going to do. Okay, so my two-dimensional distance is going to be equal to the square root of y1, so that's 4, minus y2, which is negative 4, all squared, so the absolute value there all squared, plus x1 minus x2. And that should not be negative. I don't know why I put that. That's a positive 3. I said it out loud, and I still wrote a negative. So that should just be a positive 3. Minus 3. All of that squared. Okay, so that's equal to the square root of, so 4 minus negative 4. And I did it again. Oh, no, I didn't. So this is a double positive. That becomes a plus. So that becomes 8 squared plus negative 3 minus 3. Right? So negative 3 minus 3 would be negative 6. And the absolute value there is just 6. So I'm going to have 6 squared. Okay, that gives me 64 plus 36, which combines to give me 100, and the square root of 100 is simply 10. So my two-dimensional distance here, the distance between A and B, is 10. Okay, easy peasy. So now let's do it without pictures, right? It's always helpful to have pictures, but you're not always going to have them. So I've got some examples here for us to practice with. I'm only going to do one, okay, just because I don't want this video going much longer. Okay, so right here, so obviously label your points so you don't get confused. And then just plug your numbers into the formula, right? So two-dimensional distance is equal to the square root of x1 minus x2's absolute value squared plus y1 minus y2's absolute value squared. So let's plug in. Square root of x1, minus x2 absolute value squared plus y1 minus y2 absolute value squared. 11 minus 17, so that's going to give me negative 6. Absolute value there is 6, so 6 squared. 14 minus 6 is 8. Absolute value of that is also 8, so plus 8 squared. So 36 plus 64. Square root of 100. Obviously, our answer here is 10. Okay? Easy peasy. All right, so now what about two-dimensional midpoint? Okay, so we're going to use the one-dimensional analogy again. So still have a right triangle. We're still looking at it the same way, right? But both of the legs on here, they have midpoints. Okay, they have very obvious midpoints. So it's 8 this way and 10 this way, so 18. So my midpoint's here. So that's my midpoint in one dimension between, this would be x1, and here would be x2, right? My midpoint between x1 and 2 is right there. Okay? So then what about here? Well, this would be, we'll call this y1 we'll call this y2. And actually, here, let me number that correctly. That's just going to bother me. Y1 should be here at the bottom. Y2 should be at the top. Okay. Anyway, my midpoint there, so this is 6, 4, so 10, so my midpoint's right here. So this is my other one-dimensional midpoint. So I have an x midpoint, right? I have an x midpoint here at the bottom. And that can be found by simply doing x1 plus x2 all over 2. And I also have a y midpoint. Oops. That would be y1 plus y2 over 2. Okay, where these 2 points converge, right here, where these 2 points converge, this is my two-dimensional midpoint. And it exists, obviously, at x1 plus x2 over 2. That would be my x-coordinate, right? And my y-coordinate would be my y midpoint. Okay, so one-dimensional midpoints give me the two-dimensional midpoint. Okay, so let's practice. So let's do number 1. So again, always label. Okay, so my midpoint is always equal to a coordinate pair, right? Your x midpoint, comma, your y midpoint. Or x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay? Anyway, all I'm going to do is plug the numbers in where they go. Okay, so x1 is 16 plus x2, which is negative 26. All of that over 2. That's going to give me my x midpoint. And y1 is 20 plus 36, which is y2. All that over 2. That's going to give me my y midpoint. So 16 plus negative 26, that's going to give me, I'm having a brain fart, negative 10 over 2. And 20 plus 36, that's going to give me 56 over 2. Still not done. I can reduce further. Negative 10 over 2, that's negative 5. And 56 over 2, that's 28. So my midpoint here on number 1, my two-dimensional midpoint, is going to exist at negative 5 by 28. So if point A is over here at 16 by 20, and point B is at negative 26 by 36, so we'll say it's way over here. So here's A, here's B, right? My midpoint exists at negative 5 by 28. Right, so to cap everything off, what is the Pythagorean Theorem? A squared plus B squared equals C squared. How do we use it? Arithmetic and algebra. What is our 2D distance formula, and how do we use that? Well, it's the same idea as any other formula we're going to use. You basically just put the numbers where they go. And same idea for the 2D midpoint formula. We saw what that was, and we saw how to use it. So obviously, if you have any questions over anything, let me know or shoot me an email. Come through tutoring as needed. Otherwise, that's the end of this video. Goodbye.